POLYBIOSKIN. So now we are going to look at the training center of our website, where there is a page where you can find some presentations, some slides that you can download and use them. So the next presentation will be related to an illustration of these slides that can be useful to use them as tools to explain these technologies to other people, to use them in the companies for obtaining information for students. And so now the first one will be the one related to electrospinning. So Bare, can you share your presentation?
Yes. Can you see my screen now?
Just a moment. I think we have to wait one moment. So sharing the desk.
Yeah. Can you see now?
No.
Now?
Okay, now.
Okay.
Yes. Perfect. Thanks.
Okay. Hello everybody. As Beatrice explained, I'm going to talk about electrospinning, which is the most common method to produce ultrafine fiber. And also we use this technology in POLYBIOSKIN project to produce fibers and also to modify some substrate that I am going to talk about them in the next slides. According to the ASTM standards, a textile fiber is a unit of matter that has the aspect ratio of at least 100 and which can be spun into the yarn or fabric. And as you know, we have different kind of fibers, natural fibers or chemical fibers that categorized to the comes from natural source or synthetic polymer. To produce the synthetic fibers, we have different spinning methods, including melt spinning, solution spinning, and electrospinning. Melt and solution spinnings are commercial method to produce microfibers, and we have some limitation for these techniques. For example, in melt spinning, we have to use just thermoplastic polymers, and because we are using like high temperature. And in solution spinning, we use solution polymer solution, but and we have to use the solvents for each specific polymer. And here we have to use some non-solvent, and sometimes regarding to the final applications, maybe it's not good if we use non-solvent. So it is like one limitation of this method. And as I told you, also we can just produce like microfibers, not smaller one. And here you can see the electrospinning that we are using to produce ultrafine fibers, even nano in the nano range. And as you can see here, we can use solution or melt in this technique. And in melt, also we have two categorized melt electrospinning and melt electrowriting that I am going to explain you with more details about these techniques. Here you can see and you can compare the size of the fibers. Natural textile fibers are in the range of 10 to 50 micrometer. And as you can see here, the fibers produced with this melt or solution spinnings are in the same range, but by using like advanced technologies like biocomponent or electrospinning, we can reduce the size of the fiber and we can reach even to the nanometer. And by changing the the shape of the spinnerets, we can have fibers with different cross sections, and according to the final properties that we want to reach, we can select the cross section shape of the fibers, maybe to increase the surface to volume ratio or other properties. So by this technology, we are able to produce fibers with different cross section. But if you want to just focus on electrospinning, here I brought you a brief explanation about the history of electrospinning, that at 1934, for the first time, Formhouse company invented this technology. But as you know, by now, a lot of companies are using this technology to produce their desirable products containing electrospun ultrafine fiber. But how this technology works? In this method, we have to produce polymer solution or melt, and this polymer is exposed to the electrostatic fields by application of a high voltage, and when the electric field overcomes the surface tension of the polymer at the tip of the needle, it forms a continuous jet, and this jet, by passing the distance between the tip of the needle and the collector, form this kind of loop shapes, and during this distance the solvents evaporate, and we are able to collect the fibers in the nano range size on the surface of the collector. As you can see, we have different kind of electrospinning. We have vertical or horizontal, and we can use different collectors to modify and morphology like alignment of the fiber. Here you can see the parameters that are very important and has important effect on final properties of the fibers. We can categorize them in 3 different groups. Solution parameters like the type of polymer and solvent system, because in this method we have to use conductive solvents. So for each specific polymer we have to choose the specific solvent. Solution concentration, molecular weight, viscosity, and also conductivity and surface charge density are the important solution parameters. For process parameters, we have to optimize the output voltage, flow rate, the distance between the collector and tip of the needle, and also flow rate. And there is another parameters like ambient parameters like humidity and temperature that are very important parameters, and to be able to produce fibers with desirable properties, we have to optimize all of these parameters by like machine learning or something like this to be able to produce the desirable fiber. Here you can see some different collector systems that different researchers are using to produce different fibers, like a static collector to produce randomly oriented fibers, like rotating collectors in the form of the cylinder or disc to produce aligned fiber. And also with this method, we are able to produce hollow fiber or coarser fiber. And as you can see here in this figure, and also we can collect the fibers in water bath. And here you can see some specific collectors that different research groups use to produce electrospun fiber. Here you can see some fibers that we produce in our group by our electrospinning, and I just wanted to show you the effect of the collector velocity and how it can affect the fiber alignment. As you can see, by increasing the rotating collector, we could improve the alignment of the fiber. And also it is possible, maybe for scaling up, we can use multi syringe or multi needles, and in this way we can speed up the fabrication of electrospun fiber mesh. But in this case, one of the most important things that we have to control the flow rate of each syringe, and also be sure that all of these syringes are receiving the like exactly the same output voltage. Sorry. Another interesting thing regarding to the electrospinning is the ability that we can produce also nano yarns by this method. And as you can see in these three figures, there are different methods to produce nano yarns, including millions of nanofibers that twisted to each other to form the nano yarns. And this is very interesting because in some products that you need some specific properties, for example, higher mechanical strength, or if you want to have like weave-in fabrics, you can use this technology to produce nanofiber yarns and then transform these yarns to the fabric. Here you can see some advantages of electrospinning for different applications. The most important advantage is that electrospun fibers have a very high surface area to volume ratio that would be very good properties for some specific application like biomedical applications, sensor, and like other applications. And in this method, electrospinning covers a lot of polymers, and we can use a lot of polymers to produce nanofiber by electrospinning method. Even we can combine and blend the different polymer solution together to have like blended fiber, or we can have some additives to improve some properties, and we can produce composite fibers simply by electrospinning method. So because of this advantage, this is very interesting method. Here you can see some biomedical application of electrospun mesh, for example, in tissue engineering, wound dressing, or even beauty mask or drug release. For all of this application, we can use this technology to produce our final products like biosensor, as you can see here. For example, the advantage of electrospinning for biomedical application, that also was the reason that in POLYBIOSKIN project we selected this technology to produce our products. For example, for wound dressing, we can say that electrospinning could generate a scaffold with more homogeneity besides meeting other requirements like oxygen permeation and also protection of wound from infections and dehydration for use as a wound dressing material. And in the case of tissue engineering, we can say that since the fibers are very thin, they can this kind of scaffolds can mimic the fibrous architecture of native extracellular matrix, and also for other applications like drug delivery, this high surface to volume ratio would be advantage for drug delivery applications. And as you know better than me, today's biopolymers has attracted a lot of attention, and here you can see how the number of publications regarding to these biopolymers. And also in POLYBIOSKIN we use polyhydroxyalkanoates, and as a biopolymer to produce electrospun fiber for wound healing application. And one of the challenges that we faced with this polymer was selecting the best solvents, because polyhydroxyalkanoids cannot be melt, and we couldn't use melt electrospinning, so we had to choose the best solvent to produce fibers with desirable morphology and size, and we could successfully produce this kind of fibers. And at the same time, other groups, as you can see, or other researchers are working on this to produce a different form of polyhydroxyalkanoids electrospun fiber. And also we can use also this technology to produce PLA fiber, and as I told you, there is no limitation, and it covers most of the biopolymers electrospinning, and that would be usable for different kind of polymers. Another interesting thing about this technology is that at the same time that we can produce ultrafine fibers, also by adjusting some parameters, we are able to produce nanoparticles or microparticles by this technology. And in comparison to the other technologies like emulsions method, has some advantage. For example, in this method, we are not using like some non-solvent, and for example, if we are going to produce some particles that carrying some specific additives. In this way, we can keep all of these additives inside the particles without releasing in this medium. And maybe you ask how we can reach to the particle instead of the fibers. By adjusting the most important parameters that is important is concentration, polymer solution concentration, and there is some critical solution concentrations that for each polymer we have to reach to this critical concentration to be able to produce a particle instead of the fiber. Here you can see some biomedical application of nanoparticles that, for example, we can use for drug delivery, biosensor, or also we can use this technology to functionalize the surface of different substrate directly. I mean, just by using one technology, at the same time, we are able to produce fibers, nanofibers, and nanoparticles, maybe in different layer or just modify the surface. And it's very simple, and we just need to adjust some parameters, and it can speed up the process. Here you can see some chitin nanoparticles that we use in a POLYBIOSKIN project to functionalize and modify the surface of our substrate. And here you can see that by using electrospinning, electrospraying technique, we could successfully cover some film and also some fibers. Here, for example, by changing the solvents, we could modify the size and morphology of the chitin, and we reach to the nano size of this chitin nanofibril. So it was like briefly explanation about this technology that is very interesting in these days for different application, not just biomedical. It can cover a lot of products with specific properties. At the end, I thanks to you all for your attention, and thank you. I have to thank Professor Lazzari, Beatrice, and Serena for heading this project, and all of my colleagues that helped me to do this kind of activity. Thank you.
Thank you, Dr. Bare Azimi, for your very nice presentation. And so I think that some of the participants can have questions regarding electrospinning. I know that some of them, because they are host, cannot write in the chat the questions. In any case, please take notes, because in the discussion part we can make some questions also to Bare about electrospinning.